All right, this is lesson 11, trigonometry, day 1, part 2. So we're gonna talk about Sohcahtoa a little bit. Sorry, I was doing my math. I think I started in 2003 teaching, so I've been teaching for 16 years. It's Teacher Appreciation Week, so I was just looking at that. Okay, so Sohcahtoa is sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite adjacent. But the way I teach it is this. So, left out my markers too long. So, can we see it? Sohcahtoa. It just makes sense to write it like this. It's more visual. We can see that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So there's lots of words here to explain how to do this, but I'm just gonna walk through the examples. We're looking for the sine of A. So the way I teach this is MMA fighters or boxers, they like get together and they like stand in front of each other and like, I'm gonna fight you, and like, I'm gonna fight you, and they're opponents, right? So this, whatever the angle is facing, that's its opponent or its opposite. Then right here across from the right angle, we know that that is the hypotenuse. And then whatever's left is that adjacent. Okay, so since I'm wanting sine, and sine is O over H, I would put the 5 over 13. So sine of A is 5 over 13. Done. All right, looking at the next one, we want cosine of B. So now the angle's in B. So again, we're going to talk about its opposite. We said that across from that right angle is its hypotenuse. And whatever's left is the adjacent. So because it's all the way up there, I'm just going to write right here, cosine is adjacent over hypotenuse. So looking at my A over H, that's again 5 over 13. It's not always 5 over 13, kids. It just so happens. Okay, here we are. Last one is tangent over A. Can you try and figure it out? I hope you tried it. There we go. So there's A. Again, it's facing its opponent. Across from the right angle is my hypotenuse. And then whatever's left is the adjacent. So looking at it, its tangent is O over A. So O over A is 5/12. All right, let's look at the next part. It's how to use your calculator. And this is a big mistake for students. We want to get our calculator in the right mode whenever we're working through this. So the main thing is when you get a calculator, have you guys ever picked up a calculator and you tried putting in something, and I'm just gonna do some weird stuff to it. So, and you hit graph and it looks something like, and you're like, where's my graph? I'm looking for x squared. I can't see it. Nothing's happening. Okay, so technically, don't do this all the time because it kind of drains our batteries. But the first thing you should do when you check out your calculator for the ACT is you need to do second plus 712 and then change the mode to degrees. And then it's ready for test day. So let me open it up, because what's happened is the window's all off. And you know, if you know what you're doing, that's nothing to change, right? And you could go back and there's your parabola. But if you don't know this, what this does is just puts it back to factory settings. So we hit second, and then this plus sign, and then 712. And what it does is it clears the RAM, but it changes the mode away from what we want. So we hit mode. We use the arrow key down to where it says degree, and we hit enter. Second quit, and now it's ready to go. So we're gonna try this. You're gonna try to put in cos. So here's, you know, we know we're second and 1 through 7, and this is our add, subtract, multiply. These are our graphing. But right here is our sine, cosine, tangent. And so the first one says, what's cosine of 45? So we're gonna hit cosine 45, and it's gonna tell us it's 0.707. If you did not get that, your mode is still in degrees. Let me show you what it looked like. Excuse me, in radians. If we put in radians, you got 0.525, and you're like, Cooper, I don't understand. It's because we still need to go to math. No, mode. down to degree, enter, and there it is. Okay, moving on, sine of 36 is 0.588. I would suggest you try tan 18 and sine 18 just real quick. Okay, you should get 0.325 and 0.309. Why do we need to know this? It's because sometimes you have to solve. So right here, I'm given my angle. Hey, Miss Cooper just taught me this. This guy is my opposite, and this is my hypotenuse. So again, if I was using Sohcahtoa, the only thing I'm given is O and H, which means I have to use sine, and it says the sine of 34 is O over H, x over 13. So to solve, because it says x divided by 13, I'm going to multiply both sides by 13. And in my calculator, I'm going to do 13 times sine of 34. And you can see I get 7.2695, so 7.27. Or 7.3, whatever you want to say. All right, let's try a few more. So, looking, here's my angle. This time I don't have an opposite. That's okay. I know that this is my hypotenuse, and then this must be my adjacent. So if I was using Sohcahtoa, I only have my A and my H this time, so it has to be cosine. Cosine of 67 is A over H, so x over 18. I'd multiply by 18. I'd put into my calculator, and I would get 7.03. This next one's just like it if you want to try it. So once again, that's my opposite. There's nothing at my hypotenuse, but there is adjacent. So if we're talking about Sohcahtoa, we have O and A, which is tangent. So I'm going to say the tangent of 43 is x over 9. I would multiply by 9 on both sides, and I would get 8.39. Now this next one's different. It even says it. I'm a little different. So we can see that this is my opposite and this is my hypotenuse. So I know it's sine of 52 is, but this time it's 20 over x. I don't get to choose that. It's always opposite over hypotenuse. It is what it is. So in this case, I would have to multiply by x to get it out of the denominator. So I've got x times sine of 52 equals 20. And now I want x by itself, so I would divide both sides by sine of 52. So it would look a little bit different in my calculator. This time I would do 20 divided by sine of 52. And you can say I get 25.38 for my answer. Okay. The next one is, what if I'm missing the angle? So we talked about solving several times this term, but let's say I said x plus 5 equals 10. Well, you know that the opposite of adding is to subtract. Oh, sorry. It's being bunchy. Or if I had 7x equals 21, you would say, Cooper, the opposite of multiplying is to divide. Right? We know this. So what's the opposite of sine? It's sine inverse. So here's how this is how we say it. Sine inverse. And the way we would write it is we would say sine -1, sine -1, and that would leave me with A. So in my calculator, right here, do you see in blue? So I'm going to hit second sine. So now it says sine inverse of that 0.4226, and it says 24.999. That's close enough to 25 for us. So the way to get rid of tangent is to do tangent inverse. So again, I'm going to hit second tangent 0.02679, and you can see 14.99 is pretty close to 15. Can you try these real quick? Again, we would do cosine inverse and sine inverse. You should have had 48 and 56. Pretty close. Okay, so let's do the problems then. So right here, this time, again, this should be a right angle, I'm so sorry. So we've got opposite and hypotenuse, so we know it's sine of something, that x, is O over h, 5 over 14. And I know the only way to get rid of sine is to do sine inverse. So x is going to be sine inverse of 5 over 14. So I'm going to do second sine 5 divided by 14, and I'm going to get 20.92. Or 21 degrees, somewhere around there. Okay, there's one more. Do you want to try it first? Okay, so you should have said that's my opposite, hypotenuse, adjacent. Notice I didn't write hypotenuse, and I didn't write adjacent here because otherwise it's too confusing to figure out which one I'm going to use. But if we only mark what we have, O and A, we can see it's got to be tangent because that's the only one with an O and an A. So we've got tangent of x is O over A, 5 over 14. And again, we do the inverse. X equals tangent inverse of 5 over 14. And so in my calculator, again, I'm going to hit second tangent 5 divided by 14. And I get 19.65, sure, which would be about 20 degrees. Okay, back page. Ah, yes, angle of elevation and depression. For simplicity, probably just going to do a few of these. It's just important to get the picture. The idea that I have to take words to math is too hard for many students. So let's just focus in on a few of these, and you guys can scrap the others or you can do them yourself if you want, okay? And unfortunately, I don't have my one with my answers on it, so we'll just have to, I'm sorry, I don't know what else to say. So this one says we have a 20-foot ladder leaning against a wall. So I'm just gonna draw my picture here. I've got a 20-foot ladder. And then it says, so that was my 20-foot ladder. And then it says the base of the ladder is 8 feet from the base of the building. So I know base means the bottom. And what it's saying is what is the ladder's angle of elevation? Okay, first of all, I'm gonna have to write Sohcahtoa up here at the top just so we can see it. Elevation is when you're looking up from the situation. So imagine a little ant here, and they're looking up at it. Okay, so that's my angle of elevation. Oh, you did not see that. There's my little ant. Looking up is elevation. So if I had this, here's my right angle. I've got opposite, nothing, adjacent, hypotenuse, so I'm going to have to use cosine. Cosine of some angle, or you could use x, is adjacent over hypotenuse, 8 over 20. So I would do the inverse. So theta is going to be cosine inverse of 8 over 20. I'm just going to type that into my calculator really quick. And so it would be like 66.42 or just 66 degrees. That's perfectly acceptable. The next one says, at a point on the ground 50 feet from the foot of the tree. So I know this, I had to choose some color. 50 feet from the foot of the tree. Here's the foot of the tree. So we're going to say this is 50. And it says the angle of elevation to the top of the tree. So here's my angle is 53. Oh, we already knew that, sorry. And it says, what's the height of the tree? Okay, so what I'm saying is don't go from words to an equation. Do this work of drawing the picture. It makes it so much easier. It's much easier to see that this is my opposite, hypotenuse, adjacent. So I've got tangent of 53 is going to be my opposite over adjacent, x over 50. When I multiply by 50 on both sides, 50 tangent 53, I get 66.35. Okay, this one's also angle of elevation. How about we do one more of these and then we'll do a depression. Okay, so if you want to try this one, try it really quick and let's see if you can figure it out. Okay, so it says that the kite string has an elevation of 57. So looking up the kite string, we've got 57. And it says that Richard is standing 100 feet from the point, from the point of the ground directly below the, here we are, so here's Richard, so that's 100. And it says, what's the length of the kite string? It doesn't say how high is the kite. That might be what you assumed it said, but that's not what it's asking. It's asking for this. So again, we have no opposite. We have hypotenuse and adjacent. So I have cosine of 57 is a over h, or 100 over x. We would, of course, multiply by x on both sides. X times cosine 57 equals 100. We would divide by cosine of 57. And so I get 183.6. So let's talk about depression for just a minute. Depressed obviously means someone is looking down, right? And so let's see here. Number 2 is a depression, and it says we have a 50-meter vertical tower. So vertical means straight up, and we got 50 meters, okay? And it says it's braced with the cable secure at the top of the tower and tied 30 feet, okay, 30 meters from the base. So this distance is 30, and it's wanting the angle of depression from the top of the tower. So imagine you got a little birdie up here, and they're looking down, they're pressed, so there's my angle. That's bad drawing. Opposite and adjacent, so I've got tangent of theta is opposite over adjacent, 30 over 50. We would do the inverse. So second tangent 30 over 50 is 30.96 or 31 degrees. Okay, let's do one more and call it. So the rest of them are okay, but this, we got plenty here. Okay, so here it is. I want you to see if you can figure it out. Okay, so it says from the top of a lighthouse 210 feet high. So hopefully you said, okay, that's 210. The angle of depression of a boat is 27. So looking, we've got to talk about the angle of depression to the boat. That would be my 27 right here. And it says, find the distance from the boat to the foot of the lighthouse. This is what you're looking for. Okay, so from my angle, that's my opposite and my adjacent, opposite and adjacent. So it's going to be tangent of 27 is x over 210. I would multiply by 210. So 210 tangent 27, I get 107.000, 107 it is. Okay, you can just put an X there. I don't really care. It's fine as long as you got these. Thank you.